Okay, then I would say it's 15 and we will start on time. So welcome to the webinar, Building Resilience with OT Penetration Testing. So who are we? We are from Lima Security. Lima Security is a leading OT security consulting and pen testing firm located in Austria. And we do provide, especially in Europe, OT security expertise with multiple years of experience. And we do provide 3 different types of services. We do provide OT security testing, where we do either audits or penetration tests. OT security consulting, where we help customers to increase security, identify problems with, for example, their networks, with, for example, policies, with, for example, their ESMS or OSMS, and strategically consult them how to fix these vulnerabilities or increase their security. And in the time of a cybersecurity skill shortage, we also provide trainings to increase the amount of skilled people who can work in OT security or have at least some understanding of what OT security is. And we do have a lot of customers around the world, but as you see on the map, most of them are located within Austria or Germany. And some of them are even critical infrastructure, and especially in Austria, we do a lot of critical infrastructure testing. So, Bernhard, do you want to introduce yourself?
Thank you, Felix. Also very warm welcome from my side, especially to the known faces or known names in the group already here. I'm Bernhard. I'm part of the Lima's assessment team. So I'm responsible to lead and to carry out all different types of assessments, from very technical assessments, from penetration testing up to also organizational assessments and audits. And I'm also part of the Lima's NIS auditor team, because just if you don't know, Lima's is an accredited or a qualified company to carry out full NIS audits. Yes, I'm looking forward to give you the presentation about OT penetration testing today.
Thank you. My name is Felix Eberstaller. I'm a colleague of Bernhard. I'm basically the head of vulnerability research at Lima Security, so I do a lot of deep technical testing, work with example embedded components, SCADA systems, and everything that's in between. And one of my favorite things about penetration testing in OT is, like, you have all this proprietary technology that's sometimes really old and often very weirdly programmed, or has very interesting functions. And to dig into these functions is kind of my favorite thing in OT security penetration testing.
Good. So we start off with the agenda for today. So it is about OT penetration testing. We've divided the webinar into different sections. We will start with the more theoretical parts first. So at first we talk about what is OT and what is OT penetration testing. Then we explain how we carry out OT penetration testing. And after that, Felix will give you some real-time or war stories about how we really approached things in reality. And also, I think we get some insights on what has been found by carrying out this approach. And after that, as Felix already said, we will have a Q&A section. So you have the chance, if you have questions, to state them in the chat window, and we are happy to discuss them afterwards. And if there is anything else we can do for you, just reach out to us via email afterwards. Good. So I think everyone in this webinar is pretty much aware of what OT actually is. But just to make sure, because we see or we experience in the broader population that there are sometimes some uncertainties. And so I will start with the definition of what OT actually is. And we take advantage of a definition of NIST, which we really like, which says here that OT is the hardware, software, and firmware components of a system used to detect or cause changes in physical processes through the direct control and monitoring of physical devices. So basically that means that whenever a system is interacting with the physical environment, and everything that is required to control, to monitor, to supervise those devices, this is considered as OT. And this is also what we understand as OT. And as you can see, this covers a very large spectrum of different components and devices. So not only the typical PLCs are covered by this definition, but also HMIs or associated PLC-associated engineering systems, and even in building control environments, so control systems to control a window or and the associated control system, and those protocols are also considered as OT. And this is especially, or this is exactly where Limes has its expertise, where we have expertise since as a company since then more than 10 years. Last year, that was the 10th anniversary. And I think if we sum up all the years of experience, I think we are, in total, we have more than a century of years of experience. So now that we've clarified what OT actually is, let's talk about why we want to test it. And obviously, the most important point here is we want to find vulnerabilities, because only if we know where and what vulnerabilities we have, we're able to take measures to remediate them. And therefore, we're able to reduce or prevent financial or reputational damage, and in some cases, even personal damages. Also, it's very important from a compliance or regulatory perspective, because as you are aware, there's lots of standards and regulations out there that basically, or that actually already require testing and providing assurance on the effectiveness of security controls. And last but not least, on this list, it also allows you to, if you are maintaining a certain security budget, it allows you to spend the budget on the areas that actually require them. So we talked about what is OT. We talked about why we want to test it. Let's talk about what is OT penetration testing. And to answer that, I will first explain what is penetration testing. Because sometimes it is mixed up with a vulnerability assessment or even a vulnerability scan. So sometimes we really see that a pen test is sold as a vulnerability, or the other way around, a vulnerability scan is sold as a pen test. But a vulnerability scan, vulnerability assessment is mostly automated. We also do that as one of the first phases in our assessments. But the difference here is that with the automated parts, for instance, you maybe find the vulnerability that an SMB share is not properly authenticating users, but only in the pen test, you will find out what information it actually discloses. And what, for instance, when we have seen that in reality, that on an SMB share, we find credentials to other systems, to PLCs, to engineering systems, and then are able to dig deeper or to elevate our access in the environment and really cause severe impacts. So these things you just find out with an actual penetration test. So now what's the difference between an IT penetration test and an OT penetration test? So the first one is that usually we have in OT penetration testing, we have different objectives. So we focus more on vulnerabilities affecting the visibility or the control of systems. Whereas in IT penetration testing, usually the focus is more on finding vulnerabilities that threaten the confidentiality of data. Another big difference is that usually in OT, because of the flexibility and because of the rare availability of certain components, usually you don't have full test environments available. And at the same time, usually it's very critical to maintain the availability and the integrity of those systems. So that are already indicators, as you can imagine, that it is very important to tailor the assessment approach to those requirements and to those conditions. So that is why we apply our tailored or our more or less custom OT penetration testing approach. So it's divided into certain phases. The phases itself, they apply to a very common assessment approach, but especially in the threat analysis and in the testing phase, this is where our experience, so to say, kicks in. Yes, so we usually start with initialization or a kickoff phase. So this is the very beginning of an assessment where we define responsibilities, we define the scope and the actual assessment objectives, and also documents such as a non-disclosure agreement or the permission to attack are defined and exchanged and signed. The permission to attack is something very important for us because, as you are aware, hacking is basically illegal, and with the permission to attack, we get the authorization to carry out our tests and our test cases. After that, we always have some sort of threat analysis phase. It may differ in its depth and in its length, so to say, but basically it's carried out every time. And it follows, or it has two main objectives. The first one is it is very important for us to get a very deep and detailed understanding of the environment in scope of the environment that we are going to test. We do that because of two points. First of all, we find out what are the important areas, what are the conditions in the environment that would really hurt. So this enables us to focus our resources, because that what makes us different from the real world attackers is that we are limited in our resources. The real world attacker virtually has no limit on its resources, but we also have other customers, and at a certain time we have to move on. So it's important for us to really focus on the areas where it's required, or where it makes also sense. And at the same time, while we find that out, usually in close collaboration with subject matter experts and by demonstrating how systems and processes are carried out. At the same time, we also we get an understanding of what are the critical and the most sensitive areas of the environment, so we can later take care of that and consider that. So as an output of that phase, basically, we come up with a list of test cases and test scenarios. This might be, for instance, if there is an HMI at a location, at a physical location that is a bit more exposed than others. So then we try if we can misuse that HMI, if we can get out of maybe a kiosk mode, if there is a control system application running, we try to get out of that and see if we can elevate our access to other components in the environment. This might also, another example might be a situation or a scenario where we have different physical locations, and then we try if we can also get access from one location to the systems of another location. So that would mean that also if there is a security incident, it would not be limited to one station only, but if it could spread to other locations and maybe to central systems as well. So basically, the result of the threat analysis phase is a list of test cases, test scenarios that we then plan to carry out in the testing phase. And as we already have the understanding of the sensitivity of the target environment, we are then able to take measures or to compensate the risks by either waiting for maintenance windows. We are able to take some components from the field to our lab and do extensive testing there. In some cases, we work together with vendors and integrators on site just to make sure that if something goes wrong, that someone is there and is able to step in. And also, ideally, when it comes to very exotic components and systems, then we try to target, if there is redundancy, for instance, then we target those that are not active at the moment. So we're trying to reduce the risk when it comes to actual testing. And during testing, we also obviously take care of those conditions. And for instance, we are then, depending on the actual criticality and sensitivity of the environment, we we might not carry out active testing from within the network, but we may then switch to just passively observing network traffic on, for example, mirror ports, just to make sure really not to interfere with any other components in the environment. And also when it comes to assessing systems, it might not be the case that we are doing the assessment also from the network, but maybe we log on to systems and do the assessment from the inside out. So we get privileges from our clients to log on onto those systems, and then with onboard tools and techniques, we are looking on what services are running, what protocols are available, and we basically try not to interfere with the system, with the target system. After that, usually it's not the case that we just do our things and then we leave and say goodbye. So obviously we provide a report with the findings. Felix, are you still there?
Yeah, I'm back.
Okay, very good. I was not sure if it's me or you. Okay, so after testing, we obviously prepare a report with all the findings, with recommended measures, and then there is a presentation of those findings to our clients, and the findings are discussed. And usually not even that is the actual end of our projects. So usually there is future steps such as collaborating with our clients on further consulting measures, or also such things such as a retest, for instance. Okay, so I think I pretty much covered a description of our assessment project or assessment process. And now it's Felix, to you to come up with some war stories.
Okay, so basically we do so two typical types of assessments we do quite often is like where we take a closer look at the infrastructure of an operator. We basically just take a look at the SCADA system that the operator is operating on the shop floor, and also take a look at the adjacent systems that are relevant for this kind of testing. For example, often you have this IT-OT separation where you have a jump host in DMZ, and also you often have southbound connections, like for example substations or subsystems that are not physically often well protected, like for example when you have a substation that's not on the same area or on the same site as the main plant. And in this assessment, basically, it was the first time that the operator did a penetration test. And so basically, we had to convince the operator that the penetration is doable, and also convince the engineers that the penetration test can be conducted in the environment. Because like Bernhard already mentioned, the operator didn't have any kind of spare SCADA system or spare testing equipment that could be used that is not in production or in operation during the test. So after our initial scoping call, we came up with a plan to conduct this penetration test, and that was like an offer with 12 person days, and it was planned to be start on Monday at 8 o'clock and end on Friday at 12. So the penetration test was conducted within a week, and then 2 weeks later the report is finished, and then the whole project was done. So after the customer signed, or we signed an NDA with the customer, and then began a threat analysis workshop basically on site with the customer. So we had the security officer, some engineers, and 2 penetration testers from our side. And then we just talked about the system, what are the worst case threats, what can go wrong, what are their worst fears basically when it comes to security issues. And it was quite easy to identify that the worst case scenario was basically if the IT has a major security breach, that the OT isn't affected as well. So the separation between IT and OT was very important for them. And also they wanted to test the substations because they knew that they had a lot of old substation equipment, which basically was located in different physical locations and not protected well. For example, there was like this one substation that didn't have any kind of physical security measures, like for example, a camera or motion sensors or any form of alarming. And they also want to test what would be the impact if a substation is compromised. So we started penetration testing on Monday, and after the initial setup phase, we started to work from the outside to the inside. Basically, we started in IT and took a look at the jump post and at the remote access into the OT environment. And so basically, the jump post had a major issue because the jump post was domain joined into the IT domain, which is always a bad thing, or most of the time a bad thing, because if the IT domain is compromised, the jump post is compromised as well. So all sessions that were on the jump post could be compromised. So all engineering accounts, all the credentials that are used on jump post could be exposed to an attacker. And also the jump post was not very well hardened, so it was easy to, if you had an account, to transfer files without any authorization into the OT. Because, for example, they used RDP, like a remote desktop protocol, to just connect to the jump post. And then they didn't have the protocol hardened, so we were able to transfer any kind of files onto the jump post and then later on into the OT. So on the second day, we basically moved on to the substations. So we took our equipment and connected to one of the switches in the substation and started non-invasive scans in the network, and we detected that the network was completely flat. So it was like between substation and the core of the SCADA system wasn't any kind of firewall or any kind of network segmentation. So basically, as soon as you have access to a substation, you basically could reach any kind of component within the OT network. And there's like the typical thing we find in these scenarios, like there's always this NAS system or this network attached storage system like QNAS or Synology NAS, where the operators put all the backups, all the files on there. Or for example, like also the vendor puts, or the integrator uploads stuff on there. And often these NAS systems are not well authenticated. So we were able to access a share without the credentials, and on this share, there were credentials for the whole operation or for the whole SCADA system. And also the NAS system was very outdated. So there were exploits ready available for the NAS. We didn't try them on the NAS, but we knew that the NAS was vulnerable to them. So we still had 3 days left to conduct penetration testing of the core SCADA system. So they used a SCADA system which is produced by a smaller German vendor, which is quite typical for the field the operator was in. And the vendor didn't have any kind of publicly known vulnerabilities, so that's always kind of a bit of a red flag. And so we started to dig into the SCADA system, and we just looked at different communication patterns, like for example, what does the communication look like if a logon happens? What does the communication look like if an operator or engineer triggers an action within the SCADA system? Or what does for example, what does it look like if this SCADA system rolls out a new configuration onto the clients? And within these protocols, we found some new vulnerabilities, or you can call it 0 days. And one was quite easy to catch, because one vulnerability was just that all logins performed by the operators were sent in plain text via a proprietary protocol. We just had to know how to decode the passwords, but they were not encrypted properly. Like, for example, with TLS, they were just encrypted with a proprietary static password. And the next thing we took a closer look at was like, how does the SCADA system roll out configuration files? And within this SCADA system, this was all Linux-based, so there were a lot of SSH keys lying around. And the SCADA server used the SSH keys to log into the opera station and just deploy new files. However, there was a major flaw in this architecture, because every operator station also had the same SSH key. So you could just take the SSH key from one station and laterally move to all other systems within the SCADA system. And this was kind of a new vulnerability for the vendor. And we helped to coordinate with the vendor to disclose this vulnerability, because vulnerability disclosure with vendors who didn't have any vulnerabilities or didn't disclose any vulnerabilities so far is often kind of tricky because you have to talk to them and have to tell them how, hey, this is according to a vulnerability disclosure process, and this is how we can handle these issues. So after that was done, basically we had some key takeaways from this penetration test in general. So thanks to the penetration test, we found a lot of vulnerabilities that would have not been noticed by static audits or by just talking about the system, especially the vulnerabilities within the SCADA system itself. Helped to increase the security for many different vendors, like for example, also for many different operators that use the same SCADA system. And in general, it helped the customer to improve the security of the SCADA system. And next on, basically, we can talk about embedded system. We also do a lot of penetration testing where we are contracted by a vendor to test a product, like for example, a PLC, or for example, test the SCADA system of a vendor. And these embedded systems often have some proprietary protocols, like for example, PLCs often have a protocol for engineering or protocol to deploy different files on them. And the vendor asks us to help them with pandas that he can have some sense of how good is he in accordance to certain regulatory requirements. So the vendor asks us if we can help him to assess which security level he can reach in some security standards. And we also helped the vendor to conduct a security assessment of his secure boot solution. We basically looked at how does the component boot, because implementing secure boot is often a tricky topic. And the vendor did a try of secure boot, but it was not very effective because it didn't verify certain stages of the components. So we're able to bypass this and we're able to boot any kind of different software. And we also consulted the vendor how to fix these vulnerabilities within his product. Okay. So, but after the penetration test is done, it's often not over with the project. So often we have follow-up tasks, like for example, doing consultancy work for the customer, and also doing trainings for the customers, for specialized for vendors, operators that meet the requirements of the vendor operator, so that if the vendor can so if the vendor needs, for example, a training for secure coding, we can provide them with a training for secure coding and help them to meet the certain security needs they have in the organization.
Thank you, Felix.
Okay, Bernhard, then I would hand it back to you because my setup is kind of flaky here. I don't see the screen at the moment.
Yes, but we understood you perfectly, or at least I understood you perfectly. So basically, we are already at the end of the content of our webinar. Maybe the key takeaways. So we heard about why it is important to carry out OT penetration testing, because it reveals vulnerabilities, and that is required before you can start mitigating them, obviously. Our tailored approach enables us to not disrupt production operation until now. Until now, I'm quite happy to claim that so far we really did not really interrupt with any production operation. And we do that, or in order to be able to do that, we always come up with the test cases in advance. We discuss them with our clients. We evaluate the risks associated with them, and all the steps that are carried out as part of testing are pre-authorized. So it's never the case that we just, because we heard stories that this sometimes happens, that testing teams just enter buildings or locations and just go up to any HMI and start pressing buttons. So everything that we do is pre-discussed and pre-authorized, and we create full transparency on all that we are doing. Are there any questions so far? Because I think Tobias wrote in the chat that he needs or requires some questions. No questions so far, but we have received a couple of questions in advance, which we are happy to discuss. So one of the questions were, what are the most common vulnerabilities identified in OT penetration testing? And Felix, I think that's a job for you. Okay. So I think Felix had problems with his environment. So what are the most common vulnerabilities identified in OT penetration testing? So usually we see a lot of protocols and components that provide services or protocols that simply do not provide any security features at all anymore, right? And on the one hand, sometimes there are features available that can be activated, and it's important to create awareness about what's missing and what's available on this level. But sometimes, or in most of the cases, it is required to take compensating measures and to build additional segmentation or any other type of hardening that is applicable to a certain environment. And it's very important to create transparency and awareness about all the vulnerabilities so that it's then possible to take the appropriate measures. Felix, are you back or?
Yeah, I can hear you, but I cannot see the screen at the moment.
Okay.
So if you ask me a question, I can answer them.
Perfect.
I'll answer.
Okay. When it comes to control system penetration testing, what are the first steps? So usually we start with a initial scoping call so that we find out with what environment we are basically dealing. We get an idea about its complexity, about the processes that are going on there. And on that basis, we are then able to issue a proposal. Just to give you a rough estimation, usually when it comes to assessing a control system with operator workstations, with control servers, with a couple of PLCs, with maybe an engineering station. So usually with 10 to 12 days, it's quite a good estimation to come up with a good opinion on the effectiveness of the associated security controls. And we are then also able in this first phases of the assessment, especially in the threat analysis phase, where we get the deep understanding of the environment. When we find out that it might not be sufficient, the agreed upon resources, then we are able at a very early stage to communicate it and then see how we can compensate for that, or if we limit the scope or something else. Okay. Third question: risks for control systems.
Yeah, I can take that one.
Yeah.
So basically, the question was like, what are typical risks for control systems, like on the low level field level of typical OT networks? And when it comes to typical components like PLCs, RTUs, or similar components or HMIs, they are kind of often overlooked when it comes to OT security because they are often in a insecure configuration and they're often very old and not properly maintained. And we know from well-documented public knowledge about attack campaigns like Stuxnet, Dark Energy, or similar attack campaigns that also these field devices are attacked. So it's important to increase the security of these field devices. And especially if you have modern field devices, like for example, modern PLC, they do provide a lot of security features. And what I often see in the field is like the security features are there, but they're not enabled. For example, while it's often easy to enable a password for the administrator account on PLC, often it's overlooked that they have some other features, like for example, a programming password to prevent them to be reprogrammed, or other security measures, like for example, enable encryption for the proprietary protocols. And I think it would be beneficial for the field devices if more of these security features would be enabled, if they have them.
Okay. Thank you. Okay, so we have a question in the chat. Do you also do any adversary simulation tests, meaning exploiting identified vulnerabilities? So the answer to that is yes, if desired. So basically, again, so our principles of maintaining transparency and pre-authorizing actions, they apply to that as well. But basically, it is the intention of a penetration test to actually assess and demonstrate the actual impact of exploiting vulnerabilities as well. But obviously, if it's something that would crash a system and no one is prepared for that, we are not doing that. But we are basically prepared and are able to exploit them as well. I hope that answered that. Okay, we have a second question. What kind of OT sectors, environments do you have more experience with? Industrial, utilities, communications? Felix, do you want to answer that, or should I elaborate?
Yeah, I would say the biggest is the most experience we have is like in rail, or general in energy. Why, for example, in Austria, it's often hydro-based power plants or thermal power plants. So we have a lot of experience in this sector, but we also have experience in other sectors that might not be as obvious OT systems. Like, for example, Bernhard and I do a lot of penetration testing in healthcare systems as well. And Bernhard, did I forget any sector we are often pen testing in?
Yes. So basically, Tobias also answered that more or less in the chat already. So our customers are quite distributed in a lot of different sectors. So we have customers in the energy sector, in the energy producing sector, especially in oil and gas, in water and water waste sector, but also in the very producing or producing of goods industry, like manufacturing of any goods. And yes, so I think it's quite a broad spectrum and different sectors. And yes, so if there is anything else we can do, if there are any further questions or things you would like to discuss, I think we still have a couple of minutes. And if not, I would wish everyone a nice afternoon and a nice evening.